to get a better intuitive understanding of what modulo and congruence means, we take 0. Which numbers are congruent to 0? For example, modulo 3. Well, there's all those numbers that are a multiple of 3. 6, 9, 12, and so on. You can also go in the other direction, minus side, minus 3, minus 6, minus 9, minus 12, and so on. Because, for example, 6 minus 0, that's divisible by 3. 12 minus 0, that's 12, is divisible by 3. So all numbers that are a multiple of 3 are congruent to each other, congruent to 0. Okay, so that's one way of putting it. So all numbers congruent to 0, modulo 3, are divisible by 3. Or put another way, all numbers a congruent to 0, modulo n, some general number or arbitrary number. All those numbers that are a multiple of n. So for example, we take instead modulo 5. Then all the number 5, 10, 15, 20, and so on. You can also add minus here. So all numbers congruent to 0 are a modulo 5, or all those numbers are a multiple of 5. All those numbers are divisible by 5. All these are divisible by 3. Okay, so that's congruent to 0. But let's take 1 then. Which numbers are congruent to 1 modulo 3? Take 3 to be concrete. Well, all those numbers that differ from 1 with a multiple of 3. That's 4, 7, 10, 13, and so on. All these numbers differ from 1 with a multiple of 3. 10 minus 1, that's 9, so this is a multiple of 3. Or, for example, if we take modulo 5 instead. So then it's 6, 11, 16, 21, and so on. Here we could also go in the negative side. So 1 is congruent to minus 2, minus 5, minus 8, and so on. Because all these numbers also differ a multiple of 3. Same here. If you take modulo 5, then we can go to the negative side. So minus 4, minus 9, minus 14. All of these differ also from with the multiple of 5. So each number differ with 5 here. So all of them differ with multiple of 5. So more generally, all numbers or a number is congruent to 1 modulo n. All those numbers congruent to 1 modulo n means all those numbers that differ from 1 with a multiple of n. Okay, so let us take this modulo 3 as an example. So we have that 0 is congruent to 3, 6, 9, and so on. Modulo 3. Let's not go to the negative side at the moment. We could do that also. Then we take all the numbers that are congruent to 1. That was 1, 4, 7, 10, and so on. And then 2. Just add 3 here, we get 5. Add 3, you get 8, and so on. 11. But if I now put 3 here then, but then I see I'm back here. So then we have 6, 9. So it's unnecessary to do this. So this 3 will just give me back the same again. So we see that it's enough with 0, 1 and 2. So when we are modulo 3, it's only necessary to consider 0, 1 and 2, because then we will have covered all of them. So now the rest of the numbers will be part of one of these groups here. So for example, 3 is part of that group, 4 is part of that group, 5 is part of that group, and 6 part here, and so on. And then of course we should also have the negative numbers here. You can continue in another direction, we'll have negative numbers. So all of these are modulo 3. Okay, so we can divide in the numbers in 3 groups here, at least in modulo 3. So if you have modulo 5, we have 5 groups. So it means that all these numbers differ from a multiple of 3. All these numbers differ from multiple of 3 from 1. All these numbers differ with the multiple of 3 from 2. And this differ from 0. Okay. Differ from 0 means, of course, all of them are divisible by 3. What does it mean that they are congruent to 1? Well, that means all these numbers here, if you look at all these numbers, if you divide any of these numbers with 3, you will get a remainder of 1. So all these numbers you see here are all those numbers that if you divide them by 3, you will get a remainder of 1. And all those numbers here, 2, 5, 8, if you divide those by 3, you will get a remainder of 2. And that's why you don't have a 3 here, because if you divide 3 by 3, you get a remainder of 0, and that's already have here. So these numbers here, 0, 1, and 2, those are the remainders you get if you divide by 3. And you can only get the remainder of 0, 1, or 2 if you divide by 3. We see here, for example, that all those numbers that differ from 1 with the multiple of 3, all those numbers will give you a remainder of 1 when you divide by 3. So that means, for example, if I take a number such as 125, let me take a number smaller than that is a multiple of 3 from this. For example, I could go 122, 119. But instead of jumping 1 3 at a time, I could take away several multiples of 3. So for example, I could jump here. Let's take 30, for example. 30 is 3 times 10. So I take 30 away from this, 19, and then it's 11. So this is 89, right? And then you can take away 60, because 60 is also a multiple of 3. So 29. Or I can take away 27, because 3 times 9. That's also multiple of 7, so 2. But if I know I can't take away more if I don't want to go to the negative side. So this is the smallest non-negative number I can get if I want to take away multiples of 3 from this one. And what does that tell me? Well, this number here, that's the remainder you will get if you divide 125 by 3. So by just looking here which numbers are congruent to 125 and taking the smallest one, the smallest non-negative one, then I will find the remainder. So this is, what is it? 3 times 41 with a remainder of 2. So you see that if I want to find the remainder of a division, I can do modular arithmetic. So let's take another example showing this. So let's say that I'm interested to know if, just take some random number, 2,345. Okay, is this number divisible by 7? Does 7 divide this number? Okay, what can I do then? Then I can use modular arithmetic, because now, if I calculate in modulo 7, okay, so let me now take away multiples of 7. Okay, for example, I could take away 700 from this, because that's a multiple of 7. But 2,100, that's also a multiple of 7, because that's 7 times 300. So I could take away 2100, so then I'm only left with 245. So here I've taken away 2100 from this, because it's a multiple of 7. Then I could take away 210 here, because 210 is also a multiple of 7. This is then 35. But 7 times 5, 35 is divisible by 7, so this is congruent to 0. I can take away 35 from 35 and I get 0. And that means that now when I've removed multiples of 7, I end up at 0. And that means that this number, 2345, is divisible by 7. If I instead, for example, would have gotten 1, then that means that this number is not divisible by 7, but it will give a remainder of 1. Or if I got a 2, it's not divisible and I will give a remainder of 2. So this is a very neat way of finding out if something is divisible. And if it's not divisible, finding out the remainder in the division.